Okay, in this video we're going to talk about percent error. So in percent error, you're going to calculate how far you are from where you're supposed to be. So you're going to need two values. The first value you need is the accepted value. This is also known as a theoretical value. It's going to be a quantity used by the scientific community as the general agreed upon answer. So it's what you're supposed to be getting, okay? And then the experimental value, also known as the actual value, it's what you get in your experiment. Okay, it's the value that you got. Okay, so percent error, you have just error. If someone asks you for error, it's the difference between the accepted value and the experimental value. But percent error is the percent that a measured value differs from the accepted value. So to calculate percent error, you're going to take what you got and subtract what you were supposed to get. And then you're going to take the absolute value of that number, and you're going to divide by what you were supposed to get, and then multiply that by 100. And that's going to give you a percent. So let's practice this. So the boiling point of water is 100 degrees Celsius. During an experiment, water came to boil at 97 degrees Celsius, according to the thermometer that was being used. What is the percent error of the thermometer? Okay, so I'm going to take the absolute value of what I got, 97, minus 100, which was what I was supposed to get. Okay, absolute value there. It's going to be divided by 100, which is what I was supposed to get, and times 100. You can hear a little bit of growling and a little bit of noise in the background, and that's my puppy dogs. Okay, so sorry about that. So 97 minus 100, that's going to be negative 3, right? But we're going to take the absolute value of that. So we have 3 divided by 100, and that's times 100. So that's going to be 3%, guys. Our absolute value for number 1 is 3%. Sadie, shush. Okay, number 2. An experiment was performed to determine the density of water. The results of the experiment showed that water had a density of 1.15 grams per milliliter. What was the percent error of this experiment? So again, we're going to do percent. What we got was 1.15. We're going to subtract what we were supposed to get, which was 1. The density of water is 1, right, guys? And then absolute value, and that's divided by 1 times 100. And I'm just reading this question one more time, and they don't tell us what the density of water is. I think you're supposed to know the density of water is always 1. Okay. So 1.15 minus 1 would be 0.15 over 1 times 100. So we're talking 15%. Okay, let's do a couple more. Number 3, an experiment was conducted to find the mass of 1 mole of carbon atoms. At this point, you have no clue what that means, but that's okay. The results of the experiment showed that a mole of carbon atoms has a mass of 15.78 grams. The accepted value of the mole of carbon atoms is 16 grams. What is the percent error? So I don't really know what they're talking about here, but I do know that I take what the person got. So 15.78 minus 16, absolute value, over 16 times 100. So let's see if we can do this in our head. So we have 0.22 over 16 times 100. So I got 1.375%. Okay. An experiment performed to determine the density of lead yields a value of 10.95 grams per centimeters cubed. The accepted value for density of lead is 11.342 grams per centimeter cubed. Find the percent error. So, I got 10.95, and the accepted value is 11.342, and I'm not going to write that down because you can't see it, times 100. Again, I can't do that one in my head either, so I'm going to plug it in my calculator. 10.95 minus 11.342. And remember to make that positive. Divided by 11.342 times 100. So, I got 3.46 cents error. Okay? Okay, I think by now you're getting the picture. And if you have any questions, bring those to class. Good luck!